So in this video, we're going to talk about some special cases of absolute value inequalities. So what if we're trying to solve the absolute value of x is less than c, and c is a negative number? So for example, if we're trying to solve the absolute value of x is less than -3. Well, let's think about what we already know about the absolute value. The absolute value is telling you the distance of a number from 0 on the number line. So the absolute value is always going to be some non-negative number, right? So it's either going to equal 0 or some other positive number. So are there any non-negative numbers that are less than -3? And the answer is no. Because if we look to the left of -3, where we find all the numbers that are less than -3, you can see that we don't have any non-negative numbers there, right? We're not going to find 0, and we're not going to find any positive numbers. So the absolute value of x is less than -3 will have no solutions, because the only numbers that are less than -3 are a whole bunch of negative numbers. Well, what if we're trying to solve the absolute value of x is greater than c, and c is negative? So for example, if we had the absolute value of x is greater than -6. Well, once again, we know that the absolute value is describing the distance, so it's going to be some non-negative number. So how many non-negative numbers are there that are greater than -6? Well, there are infinitely many, because if we look to the right of -6, right, where we find all the numbers that are greater than -6, you can see that we have a small section of negative numbers from -6 to 0, right? So we have some negative numbers there, but then beyond that, all of these numbers heading to positive infinity will be possible solutions to this inequality. So we actually can find infinite solutions to this inequality. So let's summarize this. If we have the absolute value of x is less than c, or the absolute value of x is less than or equal to c, where c is a negative number, that inequality will have no solution. If we have the absolute value of x is greater than c, or the absolute value of x is greater than or equal to c, where c is a negative number, that will have infinite solutions. So let's try this example and let's try solving for x. So at first glance, this just looks like any other inequality that we've been solving, right? But the difference is we have that extra term, so we need to get rid of it so we can isolate our absolute value. So this is a +4, so I'm going to do the opposite, and I'm going to subtract 4 from both sides of my inequality. So when I do that, I end up with the absolute value of x plus 1 is less than or equal to 2 minus 4, which is -2. So I hope that you realize this is why it's so important to isolate the absolute value, because now I can see that we have a special case, but just looking at this problem, I couldn't have figured that out. So this is saying the absolute value of x plus 1 is less than or equal to -2. Well, remember, less than -2, there's going to be a whole bunch of negative numbers. So this inequality is going to have no solution. So now you can go ahead and pause the video and try doing this example on your own. So once again, I hope you see that we have to isolate the absolute value first, right? Because at first glance, this just looks like any other inequality. When we subtract 13 from both sides and then divide by 3, you can see that we have a special case, because we have the absolute value of x plus 1 is greater than -3. Well, remember that greater than -3, we can actually find infinitely many possible solutions. So this inequality will have infinite solutions. So remember, when solving absolute value inequalities, you may encounter some special cases. If the absolute value of x is less than c, where c is a negative number, the inequality will have no solutions. If the absolute value of x is greater than c, where c is a negative number, the inequality will have infinitely many solutions.